So I've got this EEPROM programmer that's an open source project from Tom Nisbet, and it's called TommyPROM. It's what I use to program my EEPROMs. It works phenomenally well. And obviously it's less expensive than buying one of the commercial EEPROM programmers. But it's still on a breadboard. It's got an Arduino, it's got a ZIF socket, zero insertion force, and a couple of shift registers, and it's really that simple. But it's the programming that does the magic on the Arduino. Well, unfortunately, the ZIF socket has very short pins, and it does not always sit well, properly aligned in the, well, it doesn't sit down on the breadboard very well. And so it can pop out, which means that, of course, you don't get a good program on your EEPROM. And so for that reason, I went ahead and had some PCBs printed up of this. Now, the ZIF socket goes here, the Arduino goes here, the two shift registers go here. There's a capacitor, decoupling capacitor, which is this capacitor here, and then a couple decoupling capacitors for the IC, which are these decoupling capacitors here. And there's a third decoupling capacitor with some resistors, which I don't have on here. So there's something that he's changed between when I put this together originally and hit this. I'm assuming it improves it. And then I deliberately did not add the light on the breadboard, but I'm going to go ahead and add it on the printed circuit. And so these capacitors won't fit in these slots. So I have a number of these smaller ones. Now these are the same capacitance as those disc ones, but they're just smaller. And if you look, you can tell that they will fit into those connections very easily. Far more easily than this. So I've got 3 of those. Again, I pulled those from another project. And then I've got an LED here, which I'm going to go ahead and add. There is, and I don't know if you can tell it on camera, I'll see if I can angle it right. There is a flat spot right there. Get a pointing device. There's a flat spot right in here. So there is a flat spot on the LED. And that's what you use to align the LED. And on the board, there is a flat spot here indicating the orientation. Unfortunately, what's missing is indication of which side is positive and which side is negative on the capacitor. This electrolytic has to go in one direction, so I'm actually going to have to look at the schematic to figure out which way to put that. But the point today is to solder this up and create something that's a little bit more permanent, a little bit more sustainable than this configuration. Just about everything on this board I'm going to reuse except for the wires and the 2 disc capacitors that are just a little bit too big to fit into this PCB. I also have 4 resistors that are going to be added to this, so these will also go in. And there are 2 different values. One of them is a 330 ohm resistor, which is this one. And then the other are 10,000 ohm resistors. I'm cheating by looking at the PCB. And so those 3 will go in here, the 330, which orange, orange, black. Hop over to the the digital microscope here. Sorry, orange, orange, brown. So that's 3, 3, and brown means times 10 to the 1, so the brown means 1. So 3, 3 times 10 to the 1, or 330 ohm. If I was to look at a 10,000 ohm resistor, I've got brown, black, orange. So brown 1, black 0, orange times 10 to the 3, that's a 10,000. So 1 0 and then times 10 to the 3 being 1,000, 1 0 1,000 or 10,000 ohm resistor. At this point, it's just a matter of putting it together and soldering it up. So let's get going on that. So I'm going to slide my resistor down, and unfortunately I didn't do a great job of orienting that. And then I'm going to splay the pins out on the bottom. And then again, the 10,000 ohm, I'm bending the resistor, and then I'm going to splay the pins out on the bottom just to hold it in position. Now, I've got my own OCD issues, and so I want to make sure all three of these resistors are oriented the correct direction. Well, not correct. There's not necessarily a correct or incorrect direction. There is a consistent direction that I want to orient them, and that is such that the gold marking that it's a 5% resistor is pointed the same direction. And that would be incorrect. And then again, holding that down, I'm splaying out the pins on the bottom so that I have something I can solder to. And then before I move on, what I'm going to do is solder these 4 resistors in. I'll solder these 4 resistors in and cut the leads back so that I can move on to something that sits a little bit taller. So this would be a lot easier if I had a vise to hold it in, but I don't. Okay, now I'll spin it around and do the other side because the orientation is easier for my right hand. And then it's just a matter of cutting off the excess wire here. Now, I don't have the side cutters that everybody uses, so I do have some sharp points down here. But I'm just going to live with those. That's what the cutting mat's supposed to help me with. Alright, those in. Let's get the ceramic capacitors in. Actually, no, I think I want to put the ICs in. Let's take the Arduino out first. What I'm trying to do is I'm trying to think of shortest to tallest on these components, just so that I can hopefully make it a little easier to get everything soldered up, or at least held in place while I solder it up. Okay, let's roll those pins just a smidge so it wouldn't fit. And so just like the breadboard, sometimes you have to straighten the pins out just to help you along a little bit. There it is. Then same with this one. Yep, gotta roll those pins just a smidge. Not much. Just need to straighten them out a little bit. Now, I also understand that it might be beneficial to, instead of soldering these directly in, to solder in a socket for the IC and then place the IC directly in the socket. I'm not going to do that this time. I'm going to try this out and see. I am having a heck of a time getting this to go into the board. Try this under the microscope here. Okay, I need to roll that a little bit more. Ah, dropped right in. So with this then, you can see the pins sticking through. I need to get a little bit of weight on the opposite end of this to hold it, or some way to lift this end to hold it up. It's going to be too tall. Let's go ahead and use the LED there. And then I'm just going to do one corner and then the opposite corner. And then one corner and then the opposite corner. Okay, and that's holding that in place now. And so now it's just a matter of putting in all the pins. I'm going to go over to the other side just to give a little time for that heat to dissipate in the IC, because there is a heat transfer that takes place. And I'm doing all this soldering without flux, and I didn't really think too much about it. But I don't know that it's necessarily needed for this kind of through-hole work. That's an opinion. That's not a statement of fact. And those are the two ICs on. So the next thing is the small ceramic disc decoupling caps, which I'm going to place and solder in. And again, I'm bending the pins on the bottom to hold them in place so that they don't fall out when I flip the board over. You can see the pins there. And then it's just a matter of dropping a little bit of solder in there. And then I'll flip this around. Off the side of the screen here. And down here, last connection. And then once again, just a matter of snipping off the excess wire. And so my shopping list now needs to include some of those side cutting clippers. Alright, put those out the way. Okay, next is the LED. And again, I've got a flat side, which is up here. So I just orient that correctly and drop it in. And again, I'm going to bend the leads. And then it's just a matter of soldering in place. And then this side. And then cut those. Okay, now let's get the ZIF socket in here. And this will go right here. Get it lined up right. And I'm going to go ahead and close that just to get the little pin out of the way, or this lever out of the way. And then it's just a matter of soldering this in like an IC. I'm going to hit the corners first. And I'm going to have to hold this down as I'm doing it, because I don't know if you can see that it's tilting up. So let's get this corner here, down here at the bottom. And I'm using my finger to hold the ZIF in place. Feels like there's quite a bit of mass in there that's taking a while to heat up. And then it's just a matter of going down the line here. That's one side. Okay, that looks good. Next is the Arduino. Arduino has to go such that the power is accessible from the bottom. This is pin 1 up here. And again, pin 1 is marked with a square pad. Okay, I'm going to have to raise that up. Let's see here. This way. Okay, that'll give me at least enough that I can get that soldered in and holding on properly. I'm going to get pin 1 up here in the corner. Let's see here. It looks like it's not quite square, so let's see what we can do to fix that. It's melted, but didn't move, so maybe it was seated good enough. Let's see. Yeah, that looks good. Now, just like the ZIF socket, it's just a matter of filling it in, all the different joints. I'm actually holding the solder in a slightly different manner. I'm holding it kind of like a pencil here, and it seems to, I'm right-handed, so I'm using my left hand to guide this in, but still holding it like a pencil seems to give me a little bit better control as I continue to learn how to solder. Again, this project and the 16-bit computer project up here in the corner, and everything that goes along with it, is really the first time I've soldered anything more than just heating up some metal and hoping it actually makes a good electrical connection. Alright, that should be that side done. The PCB appears to be a little bit better, more stable on this side. Slipping and falling into the soldering iron is not a good good idea. Just for the record, there, I don't recommend it. Okay, now I'm gonna leave. I'm not even going to attempt to try to cut those pins off. And the last thing I have to solder up then is this electrolytic capacitor. And for that, I actually need to go check the schematic. Alright, so it looks like, if I'm looking at where this capacitor is, the top pin belongs to ground. It looks like it's part of the ground plane. You can see these little holes here. And the bottom pin appears to be positive. So let's wire it up that way. So top pin is ground. So that tells me that this should be the minus and this should be the plus. Now looking at the electrolytic, the minus is labeled. So this pin is the minus. Straighten the pins out a little bit here. Well, let's do this over here. So this should literally slide into place like that. Minus is there. Splay the pins out just a little bit. Then I should be good to solder that in place. So there's the electrolytic. And then once again, cut off the extra leads. I'll be picking pins up for days. And that then is done. So if I take an IC, this is an EEPROM, and drop it in here, that's then set for programming. And so I can actually program that, and then I'll be able to, with the ZIF Socket, just lift the lever, pull it straight out, no force required, no muss, no fuss, and then program that. Now, I'm not going to test this in this video. I'm going to wait and do that when I talk about my RAM, my temporary RAM. And so that's when we'll go ahead and test this circuit board to make sure I didn't do any solder bridges. But I hope you enjoyed this. Thank you. We'll see you. Wait. What's wrong with this picture? I said this side was minus, but I also said this side was where the minus was supposed to go. Yep, I installed the electrolytic backwards. So I'm going to have to worry about how to remove this and either install it correctly or replace it with a different one. So let's try that. Let's figure out what we can do about it. Alright, so I'm going to add some solder to see if I can get this to loosen up a little bit and drop. Get some wick here and see if I can actually pull. They're close enough together. I think I can span in between. So if this doesn't work, I'll end up cutting the electrolytic out. Got a fresh end on the wick here. That's all the flux evaporating there. See if I can kind of angle this thing out a little bit. Where am I at here? I think that's out. I think it's this one that needs to come out. Yep, there it is. Now the question is should I use this or should I get a brand new one? I think I can probably use that. I've got my legs poking through and it's actually being supported right now, so let me put a little bit of flux on that. Well, that loosened it up. Looks like crap. Let's see if that'll clean up because I think there's a lot of flux there. Not too bad. It could be a lot worse. And once again, like I said, we'll test it when we get into the memory module. I realized my mistake, not sitting here, but I realized my mistake as I was out running errands. I realized as I was driving around that I had put that in backwards, and of course when I got back home I checked and I did what I thought I had done, and so that's how I came to the conclusion I better double check this before I do anything with it. So that's how we managed to get here. Thank you. We'll see you soon.